Okay. So we recently instrumented ADK library in our Monocle TypeScript. So this is a small demo application which simulates the working of ADK travel agent. So we basically create some agents like flight booking agent, hotel booking agent, and in this flow we have a trip summary agent. And ADK allows us to create agents workflows in two manners. One is LLM agent and other one is sequential. So basically in sequential, all the agents of the workflow are called one by one. And if any agent is irrelevant, then it says that its agent is not relevant for this work and it proceeds to the next agents. But for LLM agents, an LLM call is made and which decides that it only calls the relevant agents. So that's the difference between sequential approach and LLM approach. So here I have two files. One is agents orchestrator, which is for LLM agent. Here our root agent is built with LLM agent, and it has three agents as tools. First, flight booking, hotel booking, and trip summary. And then other file is based on the sequential approach, which again has three agents. Mm, First is flight booking, hotel booking, and trip summary, the same thing. And the root agent is built on sequential agent. So then we run these agents, and how we instrument this ADK application with Monocle is very simple. We just load the env files that is needed for, like by default needed for the application, but we require a Monocle package, and we just call the setup Monocle line and pass our workflow name which we need, basically, which is up to us what we want to give. And after that, we just import the root agent from this orchestrator file and call our function which executes this root agent that is defined over here in runner file. So let me run this and see how it works. So let's say npm start. So by default, it calls the sequential agent. I have the commands defined over here. So when we say npm start, it calls the main sequential file. And now it says, I'm a travel booking agent. How can I assist you with your travel plans? So if I say, book me a flight from SFO to Delhi and hit enter. So it calls the agents and executes them in order. And since it's a sequential agent, then root agent calls all the agents one by one. And in the simulation, it says that your flight from SFO to Delhi has been booked. And we can continue the conversation in the same session. I can probably ask for book me a hotel also in Delhi. So it goes forward and recalls those agents. And for every request, Monocle gives us the traces. So now it says your flight and hotel is booked. And now if I go to our .monocle directory, here we have all the traces that were generated for this chat. And we ran two queries, so we get two trace files. So if I were to open our Okahu extension, here we can see the two traces. Basically, two of them are old and the most recent two, these are the ones. So if I open, and now it has the trace information where we provided the input as book me a flight from SFO to Delhi. And the final output we got was that flight was booked. And this is the structure in which agents were executed. It's starting with the turn span, then it calls the supervisor agent, that was the root agent, which decides which like how to proceed with calling the agent. So it first calls the flight booking agent, then calls the hotel booking, and then trip summary agent, which summarizes the entire conversation. And in the other trace, we can see it consists of the message that was the second query, book me a hotel also in Delhi. And then it has the output. And the trace structure remains the same. Every agent calls an inference call, basically calls the LLM, and then a tool invocation is done for the actual invocation, which is like the simulation of hotel or flight booking. And then we get the response in the another inference span. So this is how it works. And ADK support is published in our Monocle TypeScript library. And TypeScript allows us to create applications in two manners. Basically, first one is CJS application and second one is ESM. So we are working on ESM compatibility to simplify the instrumentation. For CJS, it's already there, and for ESM, it should be released by early next week. So we are working on that. And yeah, that's how it is. And obviously from the Monocle library itself, we can publish these traces to Okahu and local console also. So here we saw in the file exporter, which we got the files for the traces. So that's how it works. And yeah, I guess that summarizes the application. And we have a repository for this demo app, which we'll be open sourcing soon. So Prasad can share that to us. Yeah, that's it from my side. Anything, Prasad, you want to add?
No, this is great. Yeah, I'll drop in that repository link in the chat here in a minute.
Thanks.
All right.
Well, I had a question that so the record and playback for testing is good. What if I want to design my own tests where, the agents aren't able to do this yet, but I want to define a whole bunch, kind of a test first approach, so to speak, where this is what they need to do. And, this agent needs to call this one and, maybe a sequence order or what have you. And define that myself ahead of time and then test out the system. How would I do that? Is that possible?
So yeah, I mean it's like you can always just create that Python test file. The constructs are there. So if you know what the sequence is, you can just write the test yourself. We now also have a couple of skills for Claude that you instruct it and it'll help you generate the test code. So you sort of know what the logic is, as you said. You're gonna run this command on the agent and you expect this behavior to happen, like this tool should get called or this sub agent should get called, and the whole operation should take less than say 50,000 tokens. So you can give those instructions to your coding agent and help generate Python test code from it.
Oh, great. Oh, I like the putting a cap on the token usage. That's nice. Once they start increasing the rates, that's going to be
Yes.
very popular. All right. Well, thanks. Thanks.
Thanks.
Nice.
I'll stop sharing.